Okay. I'm going to present on the pavement maintenance and rehabilitation project in Texas using kind of integrated pavement management system analytics. We have a group that's going to be presenting today. I will start by giving kind of some background, and then Ahmed and Feng will present, and Eric was kind of leading this effort. So we're going to start with kind of an introduction, project and data requirements, then pavement analyst and the 4-year plan analysis, and then we'll go over a summary. So all state transportation agencies at the state level and at the national level are moving kind of towards performance measures or dashboards and accountability and transparency. So we have a legislative requirement. It's called Rider 55. And this legislative requirement, we are required to report how much money we're going to be spending on maintenance and rehabilitation of our roadways for a period of 4 years, and what's the expected results from this effort. So it's a good way, and it's a legislative requirement, but it's also beneficial for the state agencies. We have a maintenance budget, and this maintenance budget, is not all of it goes to maintenance towards pavements. Some of it goes towards ITS, some goes towards vegetation, some goes towards mowing, etc. So we wanted to, one of the goals of this effort was to make sure that we're trying to put as much as we can from our funds into our pavements, because pavements is our biggest asset. Actually, one of our former executives used to call it pennies to the pavements. So we're trying to scrap as much as we can and spend money on our pavements. And also this plan is kind of beneficial. It gives us a good way or a good mechanism for us to report with our commissioners, our legislators. Here is what we're doing for the next 4 years, and here is, the results that we expect. The plan that's used by TxDOT for this legislative requirement is a comprehensive plan. It includes construction project, and it also includes maintenance projects. So it includes basically any project that will impact pavement performance or will impact our scores on pavements. The plan is kind of roadway specific and is fiscally constrained. Most of the districts, their plans are roadway specific for years 1 and 2. And for years 3 and 4, some of them, or the majority of them, they will assign a budget for a county or a maintenance section. They will say kind of X amount of dollars for preventive maintenance or X amount of dollars for light rehab. And also, the plan gives us a way, to kind of show the impact of the available funds that we have, based on the available funds and based on the projects that we're selecting. This is what we expect. So when we work on these 4-year plans, we extract information from 2 different sources. We extract information from our design and construction information system. We call it DCIS. And we look for overlay projects, seal coat, rehab, restoration, widening, Super 2 highways, and others. When we started working on these plans, we were only pulling construction projects. But we realized that we were missing a lot of projects because you have some safety projects that can impact the pavement performance. You have some mobility projects that can also, you're getting a benefit from this mobility projects, that you're getting a brand new pavements. So we stopped pulling projects by kind of category or group of funding. We are pulling project by the work type, and we don't account the funds from mobility or safety, because this will sway the numbers or bias the numbers. It will show like as if we're spending huge amounts of money on maintenance and rehabilitation, but we're trying to capture the benefits that we're getting from the safety and mobility projects. And we're also trying to capture the maintenance project. We're trying to capture the in-house work. We have our maintenance sections. They do a lot of in-house work. They do a lot of in-house chip seals, or as we call them here in Texas, seal coats. And they do a lot of, sometimes some of them also do a lot of in-house overlays on in-house full depth reclamations with a seal coat, a chip seal. And we have also projects that are contracted out. So what you see, the 13023 and the 13045, these are the codes for the maintenance, in-house maintenance project and the maintenance projects that are contracted out. That we pull these projects from our maintenance management system. We pull all of this information. We pull kind of the project ID, the year, and the cost, the district, the county, the highway, the roadbed directions, and the limits for the roadway specific project, because this information is very important for the analysis, and it's needed, because for these limits, that's how you're going to reset the scores for these limits. And this information is needed for the analysis. Before kind of I start talking about the slide, TxDOT had a legacy mainframe system that was developed more than 20 years ago. And we didn't have the capability to do the analysis for the 4-year plans in-house. And we had to kind of, in a way, contract this work out to one of our universities, to one of the professors who works in the area of pavement management to do this kind of analysis for us. But now, we wanted a new system, a modern system that's web-based, that's user-friendly, that people are going to have web access, that will give us a lot of capabilities. And one of the main capabilities that we wanted is to be able to do this kind of analysis and to be able to answer the kinds of questions that administrations of transportation agencies are now asking. How much money do you need to achieve a certain goal? How much can we achieve with the available funds? So we wanted a system that can allow us to answer these kinds of questions and allow us to do the analysis, the 4-year plans. And Pavement Analyst was the right system for TxDOT to be able to do this kind of analysis. The system went live September 1st, and we finished the statewide training, and the system has been really well received by the district users. And during the training, we kind of got really positive feedback. I think from here, I'm just gonna pass it to Amit.
Thank you. Thank you, Magdy. I'm Ahmed El-Tahana, I'm a principal consultant with AgileAssets, and I'm also the technical lead on the PA project for TxDOT. As you've seen from what Magdy mentioned, the 4-year plan is a very important aspect of what TxDOT and most of the DOTs do anyway. And it's quite involved. And as Magdy also mentioned, the whole idea of doing the management plan within a PMS, it's very important to have it integrated within the system. And so what we actually offered, the pavement analyst project that we did for TxDOT was not just the analysis, was a full-fledged pavement management system that has many functionalities. One of them is the analysis that's totally integrated within the system itself. So the system obviously has many functions that you can get in, and then you have your database that has things like the condition summary, the condition data, the inventory, construction history, and so on. You have the different reports that you need for summarizing the data, administrative, and for following up on your data collection, and so on. The setup menu, where you get all the data that is needed to be prepared for your unit cost, for example, and things and such. And then we have also some utilities that will help you create the management sections. But then we have here also integrated within this whole thing is the analysis menu. And that is part of what I would like to just illustrate here. Oops, sorry. So as you actually work in with all the other aspects of the system, and you can switch back and forth between them, you can also take a look at your analysis menus right there. You can be as detailed as you want, where you can go in and create your different analyses, doing the optimization and coming up with your 4-year plan, or you can be as brief as you can in your display of the data. So this is what a 4-year plan would look like based on, for example, the DCIS. Magdy mentioned the 2 sources of the data. And then you can take a look at your projects. These are the suggested projects that's the output of the analysis. You can take a look at this in a very brief and concise form. And you can also take a look at the other source, which is the compass. Now, to get that result, there's a lot of more sophisticated analyses that have to be done, and that's what Feng is going to talk about in a second. But what I'm trying to present here in this very short interaction of mine here is that basically all this analysis that Feng is going to talk about is all integrated completely within the AgileAssets pavement analysis system. And so, as Magdy mentioned, they had to farm this out before to other researchers. Now they don't have to. So the analysis can be completely done within the system. So in the analysis, you can perform all of the other, all the activities that you do for analyzing your data, coming up with your projected goals and projected projects, and all the items that you need. And from this slide forward, I'll let Dr. Feng Hong here to talk about it. He's the man that's responsible for creating all these analyses.
I would say Eric is the man who is behind this work a lot. Yeah, my name is Feng Hong. Good afternoon. Actually, I'm working with Magdy at TxDOT. I just want to add a few words on these projects. Actually, these list of projects are from the districts. District people, they input the data into DCIS and Compass. And during the planning season, these projects are dynamic, so they're always making changes. So in order to keep updated with these projects, we have an interface actually built behind this. So that interface can automatically pull the data from the DCIS and the Compass. We can also set up a schedule to pull the data. Right now, the schedule is, it's weekly. That means if a district, let's say here from Austin, the district pavement engineer update change or add or delete whatever projects today, next Monday it will be automatically reflected in the PA. So in our analysis, it's almost up to date. Now we have all these kind of initially planned projects in place. The next step is to run the analysis, the 4-year plan analysis. Basically, this 4-year plan analysis addresses 2 tasks. First one is to using the optimization algorithm to allocate the cost for those we call the various locations. For example, we have statewide, district-wide serial code program. It has budget for each district, but there's no location identified. So the PA will recommend projects for those budget. Second task of the 4-year plan analysis is to predict the network level performance. Once we have those treatment of sections, we will see what is the predicted network level performance. Basically, we can have 2 types of predictions. The first one is if a section receives treatment, that means we are going to apply a performance jump to that section, and then it will deteriorate from the jumped performance. If a section does not receive any treatment, that means that section will keep deteriorating to the next year. This is for the performance prediction. And for the budget allocation, as I mentioned, there are 2 types of initial projects in DCIS and Compass. First one is the location specified. So a lot of projects, districts say, okay, I have to do this work in the forthcoming 4 years. If those sections are already location specified, that means the budget is already allocated for each section. However, we still have various locations projects. That means we need to use the program to pick the locations for those projects. When it comes to the treatment selection, basically we use a decision tree firstly to identify the sections which will receive either PM, light rehab, medium, and heavy rehab. This is the prediction model. Here we can see, actually the model is kind of, we call it a sigmoid model. This is the distress index. That means, with time going by, the distress increase with time. Alpha, beta, and rho, they are the parameters. So everything is bigger here in Texas. So we don't use just one set of model for the entire state. That means, for the cracking, we cannot use the same parameter for, down in the valley or here in Austin, Central Texas, or up there in Dallas. That means we need to use different parameter sets to address these variations. In order to do that, we can categorize these models into different, we call it model groups. This group will include zones, pavement family, treatment type, traffic, and of course for each distress type and ride quality. For more detail, in one of our research projects, we divide Texas into 4 regions: the wet cold, wet warm, dry cold, and dry warm, which is in the West Texas. Also for pavement families, it is divided into joined concrete, continuous reinforced concrete, asphalt pavement. For asphalt pavement, we even further divided them into 3 more subfamilies according to the general pavement thickness. For treatment types, PM, light rehab, medium, and heavy rehab, they all will have different models. And for traffic loading levels, we all know, for different traffic loading, pavement will perform differently. We have heavy traffic, medium, and low traffic. So this traffic is categorized based on the projected 20 years cumulative ESOLs. So by considering all of these factors and for all the distress indices, we have a total number of 2,160 sets of model parameters incorporated in PA. When it comes to the decision trees, actually we use decision trees to select treatment types firstly based on relevant decision variables. That means, we input the distress score, ride score, performance scores, traffic, and all other indices into the decision trees. The tree basically will recommend different treatment types. Otherwise, there's no need to do nothing for that section. So how do decision trees work? Basically, for a given section, we have all these, input variables. We just feed the input variables into the decision tree, and multiple treatments are usually recommended. For example, if based on the transverse cracking decision tree, it will recommend the PM, and based on routing, maybe the decision tree will recommend the medium rehab. The most severe treatment type is finally picked as the output of the decision tree. Since there's many variables involved in the decision process, the decision tree is very, very complex and extensive. Here is just an example of joint concrete pavement decision tree. This is the root, then we have different nodes to make the decision. So it's kind of a big picture of this decision tree. I will give more detailed examples. I think it's kind of too small to read. I will have more detailed information later on. For JCP decision tree, it's even more complex and extensive. So from the root to all the end nodes. Totally, in the decision tree we currently use, we have 148 nodes in the decision-making process. Here are some examples of the decision trees incorporated in PA. For example, we have block cracking. So based on block cracking, the tree will recommend the treatment. Let's say it will recommend PM. Then for longitudinal cracking, it will recommend, let's say, light rehab. And also for failures and traffic, it will recommend something, let's say, it will recommend medium rehab. Similarly, we have a bunch of other trees based on all those distresses scores. It will recommend different treatment results. So let's say if the most severe treatment recommendation is heavy rehab, then that means a heavy rehab will be recommended for that section. However, whether we will use heavy rehab for that section is not finally decided because it is still dependent on the funding availability. So if there's no funding for that section, that means even if there is a need for that section, we cannot assign treatment for that section. So in a word, that means we will still need to use the network level optimization tool to run this analysis to determine what kind of treatment will be finally picked for that section. So we have all these analytical steps and we have all this data right now incorporated in this PA. I call it like one-stop shop for all system. Next, I would like to present a demo on how we can use the PA to run the 4-year plan analysis.
Is it still open?
Okay.
See. Okay. You want to try to enable it, or do you want to just use this?
Okay. I can use.
Okay, let's
function.
let's show it. Okay.
Okay, thank you, Ahmed. Basically, we have a kind of, we call it pin1 access, which provides the link for all the users in TxDOT. Once we log in over there, just by the way, this login username and credentials are the same as our daily novel login. So users do not have to create a new password. So once we log in, we can have an interface like this. So Ahmed already mentioned, this interface. We have development environment, prod, QA, and training. Now I will just go through this prod system. Ask me to log in again. So this is my, same as my TxDOT login credential. So we can have, different unit to log in. These are all 25 districts, as well as the entire state. I will pick Fort Worth as an example. So I just click submit. Then we focus on analysis module, network analysis, and optimization analysis. So basically, on the left pane, we can see it's similar like Eric mentioned, in his presentation. This is called a scenario analysis. We can give a name, and we can pick a year of condition data, which is the base year. So we use this year, 2016, as the base year as our analysis start point. Then, because it's a 4-year plan, we use 4 year as our analysis length. Oops. So we also can pick what kind of decision tree we use, and we also pick work plan, which is the initial plan. It's kind of combined projects from Compass and DCIS. When we move to the right pane, this pane shows the input of the objective function, which here the objective is to maximize the condition score performance improvement due to the treatment. And our constraints, which is the county-based budget for each year. Here we can see we have 37 inputs over here because there are 9 counties in Fort Worth district. We have 4 years, that's 36 inputs plus the objective. It's totally 37 inputs. Eric did a good job. We don't have to input this, kind of numbers. This is a constraint budget. We can actually just right-click and click insert the 4-year plan constraints by county budgets. It will automatically pull the budget from the DCIS and Compass database Ahmed showed earlier. So once we have all this set up, we just right-click and run the scenario. So basically, for a district level, it will take like between 2 to 3 minutes to run this optimization work to pick up the projects. And for entire state, it will take like about 2 hours. I'm not going to run it over here. So once we have finished running this scenario, we can have some first view quick results. For example, this one is the constraint results. Basically, this column shows what is the budget, constrained budget. This column shows what is spent according to the plan. We can see these 2 columns are pretty close. That means, most of the money should be spent. And also, we have the results. This is a list of detailed projects, the plan, which includes, analysis year, what kind of treatment it will receive, and what is the cost, what is the location, the highway name, and the limits, beginning or end reference mark. If we go to right, we can see we have project status. we have two types. One is development. That means this project is determined by district. They already determined to do it for sure. And also we have a scenario recommend. That means for those various locations, district have not picked any locations. They just have budget. They don't have locations. So the program would recommend projects for those locations. So if the users, let's say district pavement engineer, is not satisfied with the results, they can make any changes on this list of projects, add or delete or change. Then they can reload this list of projects and rerun the optimization until they feel, okay, this is what I want. If we click summary reports, it will show some statistics of the results. For example, we have average condition scores in the forthcoming 4 years. We also have, treatment cost by pavement type, and lane miles by treatments type. Oops. Oh yeah. And by the way, actually in Texas, one of our key performance measure is percentage of good or better roads. So this one shows the percentage of good or better roads in the forthcoming 4 years. So if we want to export this data, we just right click over here. We can export data, to whatever format like Excel, CSV, etc. Again, this is like a first view of the results. If we want to see more detailed or more comprehensive results, we can go to reports. There's a module, reports module. Within this module, there's a dedicated folder which provides pre-established format results. The user just need to right-click it and pick the scenario. Then the PA will generate reports. So it's here. So we have a list of reports over here. I'm not going to delve into the details. I will continue with the PowerPoint and show some of the key reports we actually include in our annually published 4-year plan, like official report. I just skip.
Okay.
Yeah, thank you. Yeah, I just move down. Yeah, move down. So these are just I presented in the demo. All right. Okay, this is one of the report, the PA generated. Basically, this chart shows, oops. This chart shows the statewide percentage of good or better roads along time. The solid red line shows the percentage of good or better roads in Texas from 2004 to 2016. The dotted line, the red dotted line, shows the percentage of good or better roads in the forthcoming 4 years under the 4-year plan budget. And this blue line shows the worst situation if we don't have any budget. See, there's a gap between these two. By the way, the Texas Transportation Commission has set up a plan, a goal. What is the goal? The goal is to have 90% of our network reaching good or better roads. Here we can see, Next year, according to the plan, we are getting really close to this goal. But in the coming years, it's going down. Next one, we will see, because we have fewer budget and we have fewer treated lane miles. That's the reason why, the percentage of good or better will go down a long time. Similarly, this chart shows a comparison of good or better roads between the state, the entire state, and a district. This is for Fort Worth. So we can see actually in Fort Worth, the percentage of good or better roads used to be lower than state level, and it goes up and then go down. In the forthcoming plan years, they're getting quite close to each other. So this one can be used for Fort Worth district, to kind of evaluate their performance in their maintaining their roads. This chart shows the treated lane miles for one district, for Fort Worth district, for the forthcoming 4 years, for different treatment types: the PM, light rehab, medium rehab, and heavy rehab. Here we can see, the majority of the treatment lane miles are for the preventive maintenance. Also, it is shown with time going by, from first year to second, third, and fourth year, the treated lane miles are going down. This kind of explains why, the percentage of good, better roads will go down along years, because we have fewer planned treatment lane miles a long time. Similarly, this chart shows the treated lane miles for different pavement conditions: good, better, fair, poor, and very poor. Here we can see the majority of the pavements receiving treatment are in good or better condition right now. This kind of reflects a philosophy in pavement preservation, that is, keep good roads good. Keep the good roads good. Also, we can have a table to show more detailed results for this district. So, for example, for Fort Worth district, we can see, this is the percentage of good or better roads in the base year, which is 2016, and we will see a jump in the first 2 years of the plan year, then it will go down. Then it has 9 counties. The PA can generate results for the performance prediction for each county. We can see for most of the counties, in the first 2 years, performance will go up and then go down, except that this county, the performance will just keep going down. So this can provide the district pavement engineers some insights regarding how efficiency, they allocate their budget among different counties. So this is a percentage of good, better roads. Similarly, we have a table for the average condition score for the district of Fort Worth and for each of the individual counties. The trend is similar as the percentage of good or better roads shown just in previous slide. Last but not least, we were told almost every users in the district would like to see the projects instead of, just have a list of projects in the table. Okay, it is very important to display all these planned projects on the map. So this is a snapshot of the 4-year plan projects on the Texas road network. Basically, we can have different options. We can display only DCIS projects. We can display only Compass projects. We can also display both 2 types of projects on this map. In addition, we can impose different layers on the map, such as, in addition to the projects, we can impose the current pavement condition on the map. We can impose the traffic level on the map. So this is quite capable or we are quite capable of, running analysis and displaying the results on this map. So with this, I would summarize this presentation. Basically, with the successful launch of the new pavement management system, the Pavement Analyst in TxDOT, now we have much more capacity to run the analysis, such as a 4-year pavement management plan analysis and other types of analysis. This capacity includes, but not limited to, recommend projects through the optimization and performance prediction for each project, as well as for network level. And also it has the capacity to generate reports such as tabular reports, chart reports, and GIS reports. So this project the development of this project would not be possible without close collaboration between the team from AgileAssets and TxDOT team. Here I would also give credits to my colleagues, Jenny and Joe, for their excellent work behind this. With this, we would be more than happy to answer questions. Thank you.
Excellent presentation. Any questions at this point? You said that it takes about 2 hours to run a scenario.
The statewide.
Statewide.
Yes, not just for one district. It's about dependent size of the district. The lane miles for TxDOT districts varies from like 5,000 to 10,000 lane miles. If a big district like Austin, it will take like 3 minutes. If some small district, it will take like 2 minutes. That's the speed.
I was looking at the one slide, you had 12 years of historical performance, was fairly level for 12 years, and then through your optimization, you showed that when you spent money, that by year 4, beyond that, it was much lower. Is the expenditure, is your budgets decreasing that significantly, or you're not accomplishing as many lane miles, or is it potential for a calibration to the model to ensure that it's not maybe aggressive?
I think you've seen some of the charts. It shows that the number of lane miles treated for years 3 and 4 is much less than years 1 and 2. And the districts put a lot of effort when they're developing the plans for years 1 and 2. For years 3 and 4, they they put a specified budget for a county and or a maintenance section or a statewide for the district. And part of this, sometimes they don't know the budgets for years 3 and 4, especially for maintenance, the what do you call it, the biennium. We don't know how much maintenance budget we're going to get.
The lower number of lane miles and the budgets are going down. In the analysis, the budgets are relatively lower.
They are much lower.
Yeah, you can see by the lane miles.
And is it, right, and I was seeing that portion of it, and I was just curious if, looking back historically, those 12 years prior, the kinds of budgets that you were seeing back then, and the lane miles you were able to accomplish back then, and if those were sort of comparable to these 4 years coming up, or...
Unfortunately, we don't have the historical information of how many lane miles were treated like 10 years ago or 15 years ago. But I think in the future we'll be able. Yes, Mike?
Does that, you mentioned that if a region, or I'm sorry, a district does not know their budget, let's say, for preventive maintenance, does that mean that they don't put any money in preventive maintenance in the model line?
They put money, and we normally tell them use the same current allocation that you have, and they should put money. But like I said, they don't put effort in years 3 and 4.
We got time for one more question. Anyone else?
Yes, ma'am.
So when the next year comes, because you had mentioned that the districts put in their projects, how do they develop what projects they're going to do for that current year? Do you guys give them some sort of analysis this way, or do they choose those based
Okay, I'll answer the question kind of technical and political. Okay. We are a decentralized agency, and districts have a lot of power and authority of what to do. And the way I'm rolling the system, I'm presenting the system to them. This is a tool. It's at your discretion how you want to use it. I'm not telling them that you have to use the recommended project from Pavement Analyst. So districts have variety. We have basically 25 mini state agencies. So, and some of them, their budget is bigger than a state agency. So each one of them have their own ways of selecting projects. Some of them have ranking tools. Some of them, they have a group and drive the project. But I wanted the districts to kind of feel comfortable and feel that they have the same power that they had before. So they are using their own methods or whatever they use to select projects for years 1 and 2. And in order to do the analysis, the money for years 3 and 4 has to be allocated to a project, has to be allocated to a roadway specific. Then that's when the optimization is used, and it recommends projects for the districts for years 3 and 4. So, and what I'm telling the districts, this is optional for you to consider, for you to think about. If you can use it, you can think about it, you can ignore it. So we got some districts that ask us, how can I start the 4-year plan? You have various levels of skills and experience in the districts. So for those districts, I tell them, you can put your budget, and Pavement Analysts can recommend a set of projects for you for years 1, 2, 3, and 4, and that can be a starting point for you that you can modify, edit, and do, can be a starting point for you. Does this answer your question?
Yes.
Thank you very much. On behalf of AgileAssets, I'd like to present you these Yeti coolers.
Oh, thank you very much.
It's your favorite beverage in there.
Thank you. Thank you for your time.